Alright, so chapter 9, quantization of light. 9.1 Planck quantum theory. We have 3 learning objectives in this subtopic. The first one is to state quantum theory, to distinguish between Planck's quantum theory and classical theory of energy, and to use Einstein equation for photon energy, E is equals to hf, which is also equals to hc over lambda. Okay, so basically in 19,000, Max Planck devised a theory which is known as Planck's quantum theory. The theory explains black body radiation curves obtained from hot bodies. Okay, however, the part yang kita nak fokus based on Planck's experiment adalah, according to the theory, he made a conclusion that electromagnetic wave, EM waves, can only be released in discrete packets or quanta. Maksudnya, energy yang kita, waves yang kita ada, we know that this, contoh waves lah kan. Okay, kalau nak lukis cantik-cantik beginilah. Okay, this is our waves here. Okay, all these waves, kalau kita tengok, even in chapter 7 and 8 kita belajar, dia travel continuously. Okay, dia travel continuously. However, according to Planck's theory, he concludes that they are no longer continuous, they are actually discrete packets ataupun kita panggil dia quanta. Contoh, kamu akan ada all these wave to be packed in a discrete packet. Maksudnya kita akan ada setiap wave kita ni macam dalam sebiji-biji ni lah. They are no longer continuous. Okay, therefore conclusion yang Planck buat, energy of EM radiation is proportional to the frequency. Okay, so energy from each of these packet here is directly proportional to the frequency based on his theory. Okay, so energy carried by one of these wave packet had to be E is equals to hf. Maksudnya setiap discrete packet ini akan ada energy sebanyak h multiply with the frequency, where h here is the Planck's constant and f is the frequency of the radiation. So basically dia adalah frequency of the wave lah. The Planck's constant, h kita tadi tu, has a value of 6.63 times 10 to the power negative 34 joules second. Okay, so the Planck here has a unit of joule second, and then frequency kita tahu hertz ataupun S negative 1, therefore energy kita dalam unit joule lah. Okay, so learning objective pertama, to state Planck's quantum theory. Okay, this is Planck's quantum theory. Energy of EM radiation is proportional to the frequency. Okay, itu adalah Planck's theory dekat sini. Okay, so now we are going to look at the comparison ataupun the difference between Planck's quantum theory dan juga classical theory. Okay, so sebelum Planck came up with this idea that kita punya EM radiation is proportional to the frequency, kita dah ada pemahaman yang sebelum ni lah, which we call it as classical theory. Okay, according to the classical theory, energy is radiated in continuous form. Energy dekat sini, we are referring to the EM radiation kita, which is our wave lah. Okay, electromagnetic wave ini, sekarang dalam chapter ini kita nak bincang dia as an energy. Okay, so these waves are radiated in continuous form. This was classical theory. However, according to Planck's experiment, he managed to deduce that no, the energy is not radiated in continuous form, but they are radiated in discrete packet of energy, which means they are quantized lah. Okay, and then according to the classical theory, since the energy is in a continuous form, it is independent of the frequency. However, Planck stated that no energy is dependent on the frequency because each packet is going to have energy of E is equals to hf. Therefore, energy ini depend on the frequency because they are proportional, which was the Planck's theory lah kan. Okay, and then in 1905, Albert Einstein successfully explained the photoelectric effect by using Planck's theory. So with the help of Planck's theory ini, Einstein managed to come out with photoelectric effect, dan dia dapat explain the process of this photoelectric effect thanks to Planck lah. Okay, so we'll be looking at photoelectric effect in our next subtopic. Okay, Albert Einstein proposed that light comes in the bundle of energy. Okay, light is transmitted as tiny particle called photon. Okay, semua cahaya yang kita dapat ni, they are going to travel in bundle packet. So ini macam yang bentuk mitochondria ni, kita panggil dia photon. Okay, which this bundle of energy is called as photon. Photon ni basically adalah cahaya lah, because this wave is basically the light. Energy of the photon can be calculated by using the equation below, which according to Planck adalah E is equals to HF, di mana H adalah 6.63 exponent negative 34. Ini adalah constant, akan diberi dalam list of constant, ataupun kamu nak hafal pun boleh hafal lah. And then the frequency here depends on the frequency the light is going to travel with. Okay, cahaya, frekuensi ini bergantung kepada cahaya lah. Therefore, the energy here depends on the frequency because different light is going to have different frequency. Okay, and we know all this light ataupun EM wave ini is going to travel with the speed of the light in the vacuum. Okay, because they are traveling in the air lah kan. And we know speed of light in the vacuum adalah C is equals to F lambda. Ini basic general equation. Okay, C dekat sini adalah symbol for speed of light in vacuum and it has a constant value, iaitu C kita adalah 3 darab 10 kuasa 8 meter per second. Okay, this is a constant value, speed of light in vacuum. And then, this speed of light in the vacuum is equals to frequency multiplied with the lambda wavelength. Basically, ini dua-dua depends on the wave kita lah. So now, rearranging this equation, F is equals to C over lambda. Therefore, you can substitute this into our energy equation and you will end up with EM wave also has an energy of E is equals to HC over lambda. Okay, so dua-dua adalah benda yang sama. It depends on what information we have. Kalau nilai frekuensi tidak diberi, nilai lambda diberi, maka we use this equation lah. Because H and C are constant here. If the value of frequency is given, you can use this to find the energy of our photon. Okay. However, dalam chapter ini, the common ataupun the generalized unit for the energy of photon is electron volt. Okay, so unit yang kita akan guna commonly adalah electron volt. Okay, E kecil, B besar. 1 electron volt is basically 1 electron multiplied with 1 volt. 1 electron ini basically the charge of satu biji electron. And we know each electron akan ada charge of 1.6 times 10 to the power negative 19 coulomb. This is the charge of the electron. And then kita darabkan dengan 1 volt. Volt is also equals to joule per coulomb. Okay, so joule adalah volt is equals to joule per coulomb. And then kita multiply and then the unit of the coulomb here cancel. So you will end up with 1.6 times 10 to the power negative 19 joule. Okay, so usually equation kita E is equals to HF. H mempunyai unit joule second. Frekuensi dekat sini mempunyai unit S-1. So, energy ini berada dalam unit joule. Even when you use this equation, you are going to have your unit for H as joule second, C dekat sini adalah ms-1, lambda dekat sini adalah M. Therefore, you will end up with unit for energy dekat sini based on both this equation adalah joule. Okay, joule adalah common unit untuk energy yang selalu kita guna. But when it comes to this chapter, quantization of light ataupun energy of light, when you're talking about energy of light, commonly kita associate dia dengan unit electron volt. So kalau dalam soalan dia kata find the energy in electron volt. Okay, so bila kita guna these two equation, kita akan dapat jawapan dalam unit joule. Okay, because they are in the SI unit form. So dah dapat jawapan dalam unit joule, kena convert pergi electron volt. So basically, this thing here is the relationship between electron volt and also joule. Okay, where 1 electron volt equivalent to 1.6 times 10 to the power negative 19 joule. So nanti gunalah this relationship untuk convert joule pergi electron volt. Are we good here?
Yes, miss.
Good, miss.
Setakat ni ada soalan?
Tiada, miss.
Miss.
Okey, maksudnya faham apa Planck's quantum theory? Boleh membezakan antara Planck's dan juga classical, dua je. Classical cakap continuous form, Planck cakap no, energy is discrete. And then classical cakap energy does not depends on the frequency. Planck cakap yes, they depends on the frequency. Okay, and then we have to use the equation lah. Untuk guna equation ini, menggunakan HF ataupun HC over lambda, energy yang kita dapat memang dalam unit joule. Okay, kalau soalan tak minta dalam unit apa, you can leave it in joule. Tapi kalau soalan kata emphasize dia nak electron volt, maka kita kena convert menggunakan this relationship. Okay?
Miss, saya ada soalan.
Ya, siapa tu? Siapa Rabiana? Ha?
Yang mau convert itu unit tu final answer kah, Miss? Baru convert? Ataupun dari awal?
Final answer baru convert. Lepas kamu dah dapat energy dalam joule, baru kamu convert. Sebab kita relationship dekat sini adalah antara electron volt dan juga joule.
Okay, Miss. Faham.
Okay, so next we're going to look at the next subtopic here, 9.2. Okay, 9.2 is the photoelectric effect. Okay, this is what Albert Einstein did by using the knowledge of Planck's. He explained the process of photoelectric effect. So there are 6 learning objectives here: to define the photoelectric effect, to explain the phenomena of photoelectric effect by sketching the diagram of photoelectric effect experimental setup, define threshold frequency, work function and stopping potential, explain the failure of classical theory to justify photoelectric effect, analyze by using graph and equation the observation of photoelectric effect experiment, and to use Einstein photoelectric equation. Okay. However, sekarang kita akan cuba untuk cover learning objective A dan juga B lah. Kalau sempat kita akan masuk yang C ini. Or else yang ni semua nanti kita akan buat dalam kelas nantilah. Alright, so first thing here is we're going to look at what is meant by photoelectric effect. Okay, maksudnya definition of the photoelectric. So before we look at the definition, saya nak tekankan perkataan photoelectric ini. Okay, photo here comes from the word of photon. Photon tadi in 9.1 we associate dengan cahaya. Okay, every bundle packet of energy yang setiap cahaya itu carry, kita panggil dia photon. Okay, so photon dekat sini adalah cahaya. So photo also refer to the same thing, light lah. Sama macam kamu punya photosynthesis. Proses disebabkan oleh that light kan. Okay, elektrik dekat sini adalah elektrik lah. So basically, you are going to produce electric from the light here. Okay, daripada EM wave itu, you are going to produce the current. Okay, the definition of photoelectric effect adalah the emission of the electron from the surface of a metal when the EM radiation ataupun light of higher frequency strike its surface. Okay, apa maksud definition ni adalah you are going to have a metal surface. Kita akan ada metal lah. Okay, pada permukaan metal itu kita akan ada elektron yang akan being attracted dekat surface itu. All these electron, okay, being attached to the surface using attractive force. Okay, so kita ada banyak free electron yang akan align itself on the surface inilah. Okay, kita nak cuba emit this electron, keluarkan elektron ini daripada permukaan metal surface, iaitu emission of electron. Okay, macam mana kita nak emit this electron adalah you have to make sure you radiate, okay, awak suluh, awak strike cahaya pada permukaan ini. Okay, when you strike the light here, light which is your EM radiation tadi, okay, apa yang akan jadi adalah dia akan cuba emit the electron from the absorption of the light tadi. Okay, kita suluh cahaya pada permukaan itu akan absorb the cahaya, lepas tu dia akan release the electron. Ini adalah proses of emission of electron from the surface when EM radiation light strikes its surface. Tetapi ada syarat, EM radiation yang akan strike ini, iaitu cahaya yang datang ini has to have higher frequency. Frekuensi dia kena tinggi. Sebab kita cakap energy is equals to HF, where each packet ini is going to carry dia punya energy. So bila frekuensi tinggi, energy dia tinggi. So when they have greater energy, they can help to emit the electron dekat sini. Alright, so this is the definition. Sekarang kita nak tengok how does the process of photoelectric effect occur. So this is the experimental setup lah basically. Okay, so in our setup, it must have two conducting plates. Okay, ini adalah conducting plates kita, which is the anode positive plate dan juga cathode negative plate. Okay, anode ini kalau kamu tengok connected to the power supply yang kaki positive. And then your cathode here is connected to the negative power supply. So you have power supply in your circuit, rheostat, variable resistance, and then kita ada voltmeter dan juga galvanometer. This galvanometer is going to read the current yang akan lalu dalam circuit ini. Okay, so dalam kita punya cathode ini kita ada banyak elektron. Cathode ini is our metal surface sebenarnya. The cathode is our metal surface. Okay. For this experiment, kita ada two part of explanation, iaitu for the positive voltage dan juga when your power supply is reverse. So for the first case here, for the positive voltage, what is going to happen adalah setup dia masih sama. Okay, when you have a monochromatic light, okay, monochromatic light ini is our EM radiation lah. Okay, of suitable frequency or wavelength shines on the cathode, photoelectron are emitted. Okay, basically kita akan suluh cahaya. Cahaya yang datang ini semua, all these lights here, kita panggil dia photon, carries energy which is equals to HF. Sebab tu dia kata with suitable frequency dekat sini. Okay, so bila dia shine on the cathode, electron on the cathode will be emitted. Okay, ini adalah definition of photoelectric tadi tu. Okay, iaitu emission of electron tadi. So when you emit the electron, electron ini keluar daripada surface of the cathode disebabkan oleh cahaya yang emitted. So the electron yang keluar ini kita panggil dia photoelectron. Electron that is emitted due to the light. Okay, so lepas elektron ini keluar, apa yang jadi adalah the photoelectron are attracted to the anodes. Okay, so kita ada anode dekat sini. Anode ini bersifat positif because attached to the positive plate kan. So elektron ini are all negatively charged. So after they are emitted from the metal surface, apa yang akan jadi adalah dia akan being attracted to the anode. So dia akan bergerak menuju ke arah anode ini. Okay, so once the photoelectron are attracted to the anode, this is going to give rise to the photoelectric current which is detected by the galvanometer. So, bila ada photoelectron yang reach anode, sekarang akan ada current yang lalu because you have now completed the circuit lah dekat sini. So, kita akan ada photocurrent akan lalu. Photocurrent ini adalah current disebabkan oleh photoelectron tadi. Sebab itu kita panggil dia photocurrent. Ayolah, masih current juga. It's still the same current. Cuma kita panggil dia photocurrent dekat sini. Disebabkan the whole process occur due to the emission of the light tadi. So bila kita ada current lalu dekat sini, current yang lalu ini will be detected by the galvanometer. Maka galvanometer kita akan deflect lah to show the presence of current dekat sini. Okay, next. When the positive voltage is increased by varying your rheostat. When you adjust your rheostat, kita adjust rheostat, kita boleh ubah nilai voltage kita. Sama konsep dengan eksperimen yang kamu buat Ohm's law hari tu. Okay, as we know V is equals to I, R. Okay, when you adjust your rheostat, kamu akan ubah the potential. So when you change the potential, apa yang akan jadi? Potential yang kita ada dekat sini adalah positive potential. Potential ini akan increase. It will lead to the difference between these two plates to become greater. Bila perbezaan antara dua plate ini lagi besar, apa yang akan jadi adalah this anode now can attract more photoelectron. So lebih banyak photoelectron yang akan sampai ke anode. Once you have photoelectron reaching the anode, you are going to have more photocurrent sekarang. So lagi banyaklah photocurrent yang kita akan experience dekat sini. Maksudnya nilai current kita is going to increase. Okay, as the positive voltage becomes sufficiently large, the photoelectric current reaches a maximum constant value, IM, called saturation current. Okay, so dalam proses kita tengah adjust rheostat kita supaya voltage kita increase to have this difference in the potential between cathode dan anode yang lebih besar, kita akan ada lebih banyak current lalu, betul. As the current increases, after one particular point, kita dah reach the maximum current. Okay, maximum current. Lepas tu current dah tak boleh increase. Okay, so we call that as a saturation current. Okay, saturation current ini is defined as the maximum constant value of the photocurrent when all the photoelectron has reached the anode. Okay, so indicator untuk kita tahu when we have reached this saturation current adalah when all the photoelectron have reached the anode. Maksudnya kita dah keluarkan semua elektron daripada permukaan cathode ini dan semua elektron ini dah berjaya sampai ke anode. Okay, so if the positive voltage is gradually decreased, so sekarang kita ubah balik rheostat kita. Okay, you're going to decrease the potential dekat sini. What is going to happen adalah the photoelectric current I also decrease slowly. Even at zero voltage, contoh dekat sini, bacaan dekat sini dah tunjuk kosong. Your voltmeter now read zero. Maksudnya there is no more current, no more voltage dekat sini. There is still some photoelectron with sufficient energy reach the anode and the photoelectron current is I naught now. Okay, so kita ada dua benda dekat sini. Mula-mula what happen is, I repeat myself the whole process Okay, kita switch on, kita ada power supply dekat sini. Okay, lepas tu kita ada cathode, anode dekat sini. Okay, the difference in this potential will be read by this lah kan. Basically, bila kamu adjust rheostat dekat sini, you're going to adjust the amount of the potential that you're going to have across the circuit. So apa saja voltage yang voltmeter ini akan baca adalah the difference between these two cathode and anode. Okay, so when you adjust your rheostat, you're going to lead to the voltage to be affected. Okay, such that katakan sekarang kita increase the rheostat, voltage kita pun akan increase dekat sini. You're going to have increase in the voltage. Okay, so the potential difference between these two plates is going to increase. When you have difference between them, which is greater, there will be more photoelectron will be attracted by the anode. Okay, so when you have more electron being attracted, there will be more current that is going to flow in the circuit. Kita panggil dia photocurrent. Okay, this current will be detected by the galvanometer. When you have more current flowing in the circuit, at one particular point, when you have adjusted up to your sufficiently large positive voltage, maksudnya ini yang paling maksimum dah lah. Okay, current yang akan lalu dekat sini dah reach a constant current. Kita panggil dia saturation current. This saturation current is the maximum constant value of photocurrent. Okay, so bila kita nampak this deflection does not change, maksudnya nilai current dia tidak increase, it has stopped at contoh 5 ampere. When it has reached that 5 ampere and did not increase after that, it indicates that all the photoelectron has reached the anode. Maksudnya semua elektron yang keluar daripada sini dah sampai ke sini. Okay, after that what are we going to do is we are going to gradually decrease the voltage pula. So kita kurangkan balik rheostat supaya kita boleh decrease the difference between the cathode and anode dekat sini. So bacaan dekat sini akan mula berkurang. So at the voltmeter reading slowly decrease, okay, photocurrent kita pun akan slowly decrease. Maka galvanometer kita daripada 5 tadi pun dia akan slowly decrease. Okay, when your voltage here, the voltmeter reading has reached 0, lepas dia dah sampai 0, we can still see deflection in the galvanometer showing that there is still some value of current. Current ini kita panggil I0. Okay, current ini kita panggil I0 because the photoelectron dekat sini masih ada energy dalam diri dia untuk sampai ke anode even though the voltage now is equals to 0. Dia masih boleh sampai. Okay, next apa yang kita nak buat adalah we are going to reverse the power supply. Okay, maksud reverse the power supply adalah positive negative ni terbalik lah. Kalau kamu tengok tadi, positive on the right, now negative is on the right. So you switch the terminal. Okay, when the voltage is made negative by reversing the power supply terminal, photoelectron decreases even further to very low values since most photoelectrons are repelled by the anode which is now negative electric potential. Okay, so bila ini sekarang kita reverse, dia dah jadi negatively charged. So your anode which is connected to the negative terminal is now negatively charged. Tadi anode kita positif. Sekarang anode kita dah jadi negative. Okay, what is going to happen adalah at this particular point, after you reverse the terminal, photoelectron kita yang tadi dah sampai I0 ini, V dah kosong time tu, I kita masih I0. So you reverse the terminal. Bila you reverse the terminal, your I yang dah sampai I0 ini akan continue to decrease. It will slowly start to decrease. Okay, dia start to decrease after your voltage ini becomes negative. Because pula. Become negative. Okay, bila dia kosong, I kamu adalah I0. And then you reverse the terminal, sekarang potential kita negative, and then your current will continue to drop. Okay, kenapa current drop? Kenapa current drop adalah sebab sekarang anode kita bersifat negatif. Bila negatif, photoelektron yang keluar dekat sini will not being attracted, tapi being repelled sebab sama sifat. Negatif and negative, they are going to repel. So, as dia repel, apa yang akan jadi dekat sini adalah no longer photoelectron reaching. Okay, the anode. Maka slowly the current will start to decrease even further dekat sini. As the potential of the anodes becomes more negative, maksudnya dah negatif dia bertambah. Contoh negatif 1 volt menjadi negatif 2 volt, menjadi negatif 3, negatif 5 and so on. Less photoelectron reach anode, thus photoelectric current drops until the value equals to 0. Okay, so up to one particular point, bila kita punya galvanometer does not deflect any longer, which means the I now is equals to 0, it means that the electric potential at this particular point, maksudnya bila I kita gives a reading of 0, potential dekat sini yang negatif tadi contoh, saya cakap negatif 5 kan, dah sampai V sama dengan negatif 5 volt ini, is what we called as stopping potential, Vs. Okay, stopping potential is the minimum value of the negative voltage when there is no photoelectron reaching the anode. Okay? Are we good up to this particular point?
Good, Miss.
Awak jangan good-good je. Learning objective dekat sini adalah explain the phenomena of photoelectric by sketching diagram of photoelectric experimental setup. Maksudnya you have to show these two setup and explain what is happening dalam photoelectric ini. Don't get confused First thing adalah you set up your circuit macam biasa and then you shine your EM light dekat sini. Monochromatic light datang. Bila monochromatic light datang, apa yang akan jadi adalah electron on the surface of the cathode will be emitted. So dia jadi photoelectron. Photoelectron yang berada dekat luar ini bersifat negatif and your anode here is connected to the positive plate, so they will attract each other. This causes current to flow in the circuit. Current yang lalu ini kita panggil photo current. Galvanometer kita akan deflect. Okay, and then in order to increase the current basically, apa kamu buat adalah you vary your rheostat. When you vary your rheostat, your voltmeter here will have a greater value daripada yang tadi. This is because the difference between these two plates has now increased. So potential kita dekat sini pun akan increase. So when your potential here increase, it will cause this plate here to become more stronger lah basically. So bila dia lagi kuat, dia boleh attract lebih banyak elektron. When it attract more electron, dia akan allow more current to flow dekat sini. And then your galvanometer akan start to deflect dengan nilai current yang lebih besar. Okay, and then kita adjust lagi rheostat supaya voltage kita lagi besar. Bila voltage lagi besar, anode jadi lagi kuat untuk absorb lebih banyak elektron. Bila dia absorb more electron towards dia akan allow more current to flow. Until one particular point when you see that your galvanometer reading of the current has stopped increasing. It means the current has reached the saturation current, iaitu IM. IM ini adalah maximum constant value of the photocurrent. Proses ini indicates that all the photoelectron dah sampai ke anode. Okay, all the photoelectron dah sampai ke anode. Okay, and then sekarang apa kita buat adalah kita slowly decrease the voltage. To decrease the voltage, kita kurangkan balik rheostat kita. You adjust back your rheostat so that the difference between these two plates reduce. Okay, bila reduce, apa yang akan jadi adalah nilai photocurrent tadi itu akan mula berkurang juga. Contoh daripada 5 ampere tadi, dia akan berkurang. Dalam proses dia berkurang, when your voltage has already reached zero, maksudnya there is no more potential difference between these two plates. Dah tak ada perubahan dah, dah tak ada perbezaan dah. Okay, you can still see current flowing in the circuit. Walaupun voltage sama dengan kosong, kita masih ada current yang lalu. This current is known as I0. Okay, I0 occur when V is equals to 0. Okay, after that, to further reduce the current, sebab daripada 5 ampere tadi, current kita contoh dah sampai 3 ampere. Kita tak nak current langsung. Kita nak current kita sama dengan kosong. Okay, walaupun voltage dah kosong, current belum sampai kosong. Therefore, what you do is, you reverse the terminal. When you reverse the terminal, your potential now becomes negative potential. Okay, so this indicates that your anode now is a negative terminal. So bila dia negative terminal, current yang tadi tengah flow dekat sini, yang kita ada 3 ampere current yang tengah flow, due to still there is some photoelectron reaching, apa yang akan jadi adalah dia akan mula repel the electron. Dalam proses dia tengah repel ini, okay, dia tak allow electron sampai. So bila electron tak sampai, dia tak boleh allow current to flow lah, because it does not have electron to flow across dia. Okay, so when you slowly repel the electron, you are going to slowly decrease the current further daripada I0. Okay, when you slowly decrease the current, after one particular point, bila there is no more current flowing in the circuit, this galvanometer read 0 lah kan. Okay, this voltmeter tadi sekarang akan deflect in the negative side lah. Tapi kalau kita tengok bacaan voltmeter kita kosong, contoh 5 dekat sini. So dia hanya akan deflect one side sahaja. Bila dia deflect ke sini, maksudnya you have reversed the terminal. Kita terpasang terbalik lah. Ramai orang yang buat benda ni waktu kamu buat Ohm's law eksperimen hari tu. Kamu letak terbalik, so this indicates that positive negative kita terbalik. Okay, konsep dia sama juga dekat sini. Okay, when you reverse the terminal, bukannya kita cakap kita akan ada negatif, dia masih akan baca in the positive side, cuma they are in the opposite direction sekarang. Okay, so when your I now is 0, katakan voltmeter kita baca 5 volt. 5 volt ini indicates that this is the potential that you have used to stop the current. So kita panggil dia stopping potential. Okay, which is the minimum value of negative voltage when there is no more photoelectron reaching anode. Maksudnya dah memang tak ada apa-apa elektron yang akan keluar dan sampai ke anode ini. Okay, so this is the process of your photoelectric effect. Are we all good?
Good, Miss.
Okay, betul. Alright. Saya nak tengok next part dekat sini, iaitu equation or graph on photoelectric experiment. Okay, basically graph ini menunjukkan the process of how does the current changes with the potential. Okay, so tadi kita cakap kita akan ada photo current yang akan flow in the circuit. Okay, due to that photoelectron reaching the anode and then the anode allow the current to flow, so kita panggil dia photocurrent dekat sini. Okay, photocurrent ini mula-mula dia akan slowly increase sampailah dia reach the maximum current, di mana after that dia takkan increase. Iaitu kita panggil dia IM saturation current. Okay, saturation current dekat sini adalah where you have all the photoelectron have already reached the anode. Okay, your current has stopped flowing. At this particular point, your potential here is a positive potential. Positive potential. Okay. Kalau kamu tengok pun dekat sini, bila kita lukis current dekat sini, according to this graph here, your current here is on the positive side of the voltage. So, kita punya x-axis here is, y-axis here is going to show the variation of the current. X-axis akan show the variation of voltage. Voltage kita dua je, iaitu before you reverse the terminal dan after you reverse the terminal. Current kamu pula daripada IM to I0 sampailah I kita sama dengan kosong. Okay, Alright, dalam proses dia slowly naik ke IM ni, kita tak tengok lah. Kita nak tengok pada part bila dah sampai saturation current itu. Okay, saturation current, and then what you do is you decrease the potential. Bila kita decrease the potential dekat sini, iaitu you are trying to slowly approach ke zero. Okay, bila your potential is zero, kita cakap tadi masih ada current flow, iaitu I sama dengan I0. So according to this graph, your potential is zero, your I now is I0. Masih ada current. And then you reverse the terminal. Bila kita reverse the terminal, potential kita bersifat negatif sekarang. We have negative potential. So at that particular point, your current slowly start to decrease. Sampailah current kita pula yang sama dengan kosong. Your current has reached zero value here. Okay, bila current kita sampai kosong, potential dia for the current to be zero is the stopping potential, iaitu Vs. Okay, this is your Vs. So, when the question asks to sketch the variation of photoelectric current and the voltage dekat sini, awak kena tunjuk your IM, I0, Vs, and then kena ada bahagian before reversing the terminal, after reversing the terminal. Semua ni kena adalah to show the difference from IM to I is equals to 0. Okay, alright. The potential energy U due to the retarding voltage, stopping potential tadi, Vs tu is also known as retarding voltage. Benda yang sama Okay, so kita akan ada potential energy dalam case ini disebabkan oleh potential tadi, iaitu stopping potential, is equals to the maximum kinetic energy of the photoelectron. Okay, so the stopping potential which gives you a potential energy now is equals to the maximum kinetic energy of the photoelectron. And we know kinetic energy adalah half mv square. Since the kinetic energy here is maximum, velocity dekat sini pun kita associate dengan maximum velocity lah. Potential energy pula adalah disebabkan oleh electron, charge of the electron multiply with the stopping potential. Okay, E dekat sini adalah charge of the electron which is 1.6 times 10 to the power negative 19 didarabkan dengan potential kita, iaitu stopping potential. Okay, why is your U is equals to EVS dekat sini adalah is the potential used to stop every single charge, iaitu elektron kamu lah. Okay, sebab tu kita darab dengan charge of electron dekat sini. Okay, next adalah work function, threshold frequency and stopping potential. Kita nak tengok in details dari segi definition dan juga equation dia. Okay, what is work function? Work function is defined as the minimum energy of EM radiation required to emit an electron from the surface of the metal. So tadi kita cakap kita akan ada metal and you're going to have electron here. All these electron are being attracted to the metal surface ini. And the force that is holding the electron and metal surface ini adalah attractive force. Attractive force. In order to overcome this attractive force, iaitu to emit the electron ini, you must have sufficient energy lah dekat sini. So the minimum energy to overcome this attractive force is known as work function. Iaitu energy yang paling minimum you need in order to emit the electron. And this work function always depends on the type of the metal dekat sini. So different metal is going to have different attractive force between the electron. Therefore, different metal requires different minimum energy to overcome these forces lah. Okay, so W0 ini is also known as minimum energy, which is HF0. Sebab kita tahu energy dekat sini adalah sama dengan HF. Disebabkan dia adalah minimum energy, the frequency here becomes the minimum frequency, which is, kita guna symbol naught here, F naught. So basically your work function, which is the minimum energy here, is equals to H F naught. H masih constant, 6.63 times 10 to the power negative 34. F naught kamu pula is your threshold frequency. Kita panggil nama dia threshold frequency. Threshold frequency pula adalah the minimum frequency of EM radiation required to emit an electron from the surface of the metal, iaitu the minimum frequency, because your W here is directly proportional to the F naught. Bila W adalah minimum energy, maka F naught adalah minimum frequency that each of your EM radiation going to carry, iaitu frekuensi yang paling minimum required supaya kita boleh overcome this attractive force. Since C is equals to F lambda, therefore kalau threshold frequency dia akan sama dengan C over lambda naught. Lambda naught ini pula adalah threshold wavelength. Threshold wavelength. Okay, as you can see, your F naught is inversely proportional to the lambda. So bila kita cakap threshold frequency adalah the minimum frequency, iaitu frekuensi yang paling rendah, maka wavelength kita akan jadi wavelength yang paling besar because they are inversely proportional. Okay, so your threshold dekat sini adalah maximum wavelength required to emit the electron lah. Okay, and then stopping potential. Stopping potential adalah BS tadi, iaitu bila when your current is exactly equals to 0. Is defined as the minimum value of the negative voltage when there is no photoelectron reaching the anode. Okay, are we all good?
Good, Miss.
Okay, first thing dekat sini yang kita belajar tu dia adalah what is Planck's quantum theory. Kita cakap setiap wave kita ini adalah satu packet bundle dekat sini. Okay, ini kita panggil dia photon, cahaya. Cahaya ini ada energy E is equals to HF. And then kita cakap macam mana cahaya ini produce the current, photoelectric. Okay, and then ini adalah the process lah. And then dekat sini we have talked about the relationship in terms of graph for the photoelectric current and also the potential. How does the potential help us to reach that zero current dekat sini? And then kita relate the potential energy dengan maximum kinetic energy dekat sini. Alright, after that we have looked at few terms, iaitu work function, threshold frequency dan juga stopping potential. Okay, dan equation dekat sini tak adalah baru pun. Work function ini is basically minimum energy. Energy adalah HF. When your energy is minimum, frequency minimum lah. Cuma kita panggil dia threshold frequency. Itu saja. So work function dekat sini is still a measure of the energy basically, sebab minimum energy. So unit dia adalah joule dekat sini. Threshold frequency masih frequency, so unit dia adalah S-1 ataupun Hertz. Okay, and then we have the definition of stopping potential, which sebenarnya kita dah tengok dalam proses of photoelectric effect ini.